Hello everyone, my name is Farrokh Azad from Sweco Fire Engineering team. We are going to start with principles of fire engineering and kind of what is applicable to fire safety in terms of regulation point of view, or let's say the governing regulation controlling fire safety requirements in the UK. So we have Town and County Planning Order 2015, which is applicable for planning applications, particularly Gateway 1, which has been introduced during last year. We have Building Regulations 2010, particularly Part B, which sets the requirements for life safety in buildings, and a Part B certification will be issued if satisfaction with Part B demonstrated during the design and construction. And we have Fire Safety Order 2005, which is applicable for buildings when they are handed over and are in use. So, so planning, obviously, or the concept design for fire safety during planning is controlled by Gateway 1, during the design and construction by Part B of building regulations, and obviously for the rest of the lifetime of the building, it will be under Fire Safety Order for maintenance of the fire safety systems or design provided in the building. So I just attached standard rebar stages here, probably up to stage 3. I would say a planning application, the fire safety statement of gateway requirements are applicable from a stage 3 until probably end of construction, which is a stage 5, is the area which is normally under Part B. And then after handover and use of the building, fire safety order is going to be the governing regulation, making sure the fire safety systems and requirements stays in the building. So I thought I can, so for Gateway 1 or planning application, and for fire safety assessment or fire safety order, both of those regulations making references back to building regulations, which is setting out the fire safety requirements in a building. And particularly in Part B, we have 5 sections, or let's say 5 main areas for fire safety to consider. B1 is means of warning and escape. B2, internal fire spread or the lining materials. B3 is compartmentation and the structural fire resistance. B4, external fire spread, and B5 is fire brigade access and facilities. And under each of these sections, there are requirements with regards to that specific area of the fire safety. So this is how building regulations in the UK is structured. I understand across the globe, probably there are other regulations applicable to each country or each area, which these principles maybe are structured differently, but they are the main concepts. It doesn't matter where the fire safety is designed, there are the key items which is normally expected to be captured in fire safety design. Normally, it is not only for the UK, I would say in the globe. Normally, there are 2 routes for compliance with fire safety requirements for buildings. The first route is a prescriptive fire safety design, which means one of the known guidance documents will be followed, and the design will be as per the code, basically, or as per the guidance document. In the UK, we have approved document or approved document B for fire safety, BS 999, BS 9999 for non-residential building, BS 9991 for residential building, BB 100 for schools, HDM 0205 for hospitals, and a few other guidance documents. It is good to mention that obviously the guidance documents are providing limited guidance. They are not as flexible as sometimes we are expecting. So normally the design achieved following strictly these guidance documents is not going to have the flexibility normally architects happening, or maybe the client may wish to have for the building. So the next route, which gives a better flexibility and a better fire safety design, I guess, for the buildings, is a performance-based fire strategy design or fire safety design, which means we are going to look at the design and the building on individual basis, and we assess that building on the basis of the performance of fire safety provided in that building, from fire detection alarm system to compartmentation, to a sprinkler, to any other systems which is intended to be used in the building. So particularly in the UK, BS 7974 is providing guidance to follow a performance-based design for fire safety. This guidance providing guidance for application of fire safety engineering in general, and defining the steps needed to be taken by a fire engineer to come up with a fire engineered design. And normally it is started with the QDR, we call it, qualitative design review, which the objectives of the design will be set, and then through a scientific route, normally it will be demonstrated. So when we are going through a performance-based design, we need, as fire engineers, we need to put a case together first to set the benchmark as we are measuring against, which is normally human tenability criteria, because mainly we are designing for life safety. Other objectives can be set, for example, property protection or environment, which is normally important for infrastructure, facilities or buildings which continuous operation is required. But in general, for normal buildings, we set the benchmarks for human tenability, and then we go through a route of either a comparative or deterministic study to demonstrate those benchmarks have been achieved or even exceeded. So again, prescriptive fire safety design or performance-based is kind of the mainly two routes everyone every fire engineer can follow. So there are two pictures on a slide. So obviously the right-hand side is obviously if you have a very high-rise building, probably with a complex internal arrangement, then a performance-based design is applicable, because this is not an ordinary building. This is not a building with a normal height or normal design. Then there is not enough guidance provided in typical fire safety guidance documents. So basically, performance-based design provides us for a route to go for a special design based on the height of the building, the number of occupancy, the type of the structure, and any other design considerations. Fire safety engineering. So we talked about we can go through a performance-based design, but we said we need to use fire safety engineering. So what is fire engineering? What a fire engineer is doing? So normally a job of fire engineer for us is either code consultation, which means advising design requirements as per the books, as per the guidance documents, or we use fire engineering design, which is going to be utilizing application of science and engineering principles to protect people, property, and environment from the harmful and destructive effects of fire and smoke. So through that journey, most of the time we use calculations, mathematical calculations. We use principles of physics and sometimes chemistry for reactions of different materials, and also we are using computer modeling. So screenshots on the screen are showing in the very left-hand side CFD modeling, which is a tool we are using for the behavior of the fire, behavior of a smoke within a building, within a geometry, to understand how smoke and the temperature and the radiation is going to affect the building and different areas of the building, excuse me, if a fire happening. The picture in the middle showing a structural analysis for the structure of a building when a fire is happening, and it is more for defining the required fire resistance for structural elements. And the picture on the very right-hand side is an evacuation modeling, which is demonstrating if the means of escape provided in a building, a means of escape, it can be a stair, it can be lifts probably, which we are going to touch it later, is adequate for the building and number of the people in the building. And if a fire happening, how the sequence of evacuation is going to happen, how many people are going to use the stairs, how many people probably are going to use evacuation. And this computer modeling can inform us with more information of how the evacuation load will be distributed through the means of evacuation from the building. So that's kind of part of the job we do for bespoke design or performance design. I thought it would be useful for us to quickly have a look to see what has been happened during last maybe 4 years, particularly after Grenfell. So particularly in the UK, obviously we had fire incidents before, and we learned through them. For example, Lakanal House is one of those incidents happened before, and every time an incident happening, we learn from it, we improve from it, and hopefully we try to fill the gaps. So obviously after Grenfell, which has happened on 2017, then a few updates has been happened, a few notices has been issued by the government. Obviously that incident was more relevant to the facade. However, means of escape was part of the items which has been identified not being adequately provided or adequately protected by the time incident happened. And then after that, on 2018, towards the end of 2018, we had building regulations updated in the UK, addressing more requirements for a facade fire or facade protection, and also asking for a better and more robust means of escape through the building. Ventilation through the corridors, for example, and the stairs, and from that point, discussions started to understand if lifts actually can be used as means of escape, as a safe means of escape for a building. And then after that, we had on 2019 approved document B updated, outlining requirements from Part B for the use of the buildings, and still updates are coming as we know. We have the Fire Safety Act on 2021 presented, and then we had building safety regulator as a rule for overall fire safety of the buildings introduced, which they control 3 gateways: Gateway 1, 2, and 3. And as I just touched earlier, Gateway 1 is planning, which some guidance document issued. So a fire safety statement as part of a planning application is needed at the moment, which needed to support buildings, particularly buildings over 18 meters in height, which I think we call them high-rise building. And then obviously Gateway 2 and Gateway 3 will be introduced, and will be introduced in more detail as they're coming. So I think I provide a bit of background on where we are in the fire industry. So I'm going to go and kind of go through the topic which is more relevant to our discussion after this introduction, which is firefighting lift. And I just thought it would be good I can just kind of set when we need to provide a firefighting lift in a building. What is the requirements triggering the use of a firefighting lift in a building? So obviously a firefighting lift, if it is provided, it needs to be provided with protection measures, controls, and signals that enable to be used under direct control of the fire rescue, and installed in accordance with BS EN 81, Part 20 and 72. In terms of the requirement for having or for a need for having a firefighting lift in a building, there are mainly 2 criteria. When we have a building over 18 meters in height, which is a high-rise building, or we have a building which has a depth or basement levels deeper than 10 meters, then a firefighting lift should be provided as part of the firefighting shaft. What I would like to kind of highlight here is providing a firefighting shaft doesn't mean a firefighting lift needed to be provided as well. So the table 17 from BS 9999 outlines when we need to provide a firefighting shaft arrangement, and only in two occasions or 2 design proposals we need to provide firefighting lift as part of the firefighting shaft arrangement. And as I mentioned, only for the building over 18 meters height or depths greater than 10 meters. Other than that, there is no need to include a firefighting lift as part of the firefighting shaft. That's what BS 9999 asking. And also, probably it would be good to mention another item here as well. It is not needed to have one single firefighting shaft serving all levels above ground and below ground. So it can be one shaft or one firefighting lift serving upper ground levels, and one shaft or one separate firefighting lift serving below ground levels. So that's kind of the requirements for firefighting lift. Obviously, when firefighting lifts provided, there are some design considerations with that. So as probably you can see on the screen, a standard arrangement is needed for residential buildings or buildings serving flats, or for any other building. There is a minor change between these two, probably not for this session to go through, but I thought it is useful to just mention that here. But in general, we need to achieve a protected enclosure for firefighting shaft, including firefighting lift. But if you wanted to just focus on firefighting lift, because when we're talking about firefighting shaft, it has a few elements. So firefighting lift is just part of it. So if a firefighting lift is provided, we expect the overall enclosure achieve 120 minutes fire resistance. It needs to have certain dimensions. Signage should be clear. A backup power supply is needed. Lobby protection is needed for fire lift opening into and at every level. Smoke ventilation is needed for the lobbies mainly. However, in the recent updates of BS 9991, which is residential, it is suggested that as a solution, maybe firefighting lift can be pressurized as well for protection of ingress of smoke. That document still is on draft, not issued yet, but that's something already mentioned there. But we will see if it is concluded with that requirement. Control system and interface with fire alarm for grounding of the lifts. So if a fire happening in the building, lifts grounds at ground level or any alternative level, depending on the design of the building or fire strategy of the building. Communication system, water protection to the lift, and also maintenance routine for the lifts is obviously a requirement. Evacuation lift, probably another hot topic at the moment for fire safety design. So where a lift is part of evacuation sequence of people. So a lift is designed as part of fire strategy. Let's put it this way. It should be an evacuation lift installed as per BS-EN 81, Part 20 and Part 70. There are some design considerations associated with that, which is an evacuation lift should not be considered solely as the only means of escape. So we need to have stairs in the building as the minimum, and then evacuation lifts also can be provided. The overall evacuation regime of the building should be considered. So it is important to know if the building is supposed to be evacuated simultaneously, like all occupants at the same time from all floors, or it is going to be a phased evacuation, which means maybe a few floors will be evacuated, and then in a sequence other floors will be evacuated, or actually it is a stay put like a residential. So only one flat is supposed to be evacuated at the when fire detected. So it plays a role to identify if provision of evacuation lift is actually effective to evacuation of the entire building. So it needs a holistic review. So for example, if you're talking about simultaneous evacuation, overcrowding and queuing can become an issue, because if everyone expected to go and stay and wait for a lift to come back again, so is there enough protected space provided for them to wait there? Is the queuing is going to cause any issues? So that should be explored in the fire strategy or the design as well. Also, the operation of an evacuation lift from BS 9999 requires assistance, either assistance via management, or fire marshals are provided, or actually it can be supported by fire service, which is expected only during firefighting. Probably worth highlighting this that fire service is not expected to to evacuate the people. So the building and the fire strategy should be designed in such a way that people can evacuate, ideally before fire brigade arrival, or if fire brigade arrived, then they can continue their evacuation without interface with the fire operation. So that's obviously one of the items which is normally addressed in the fire strategy. A lobby protection or refuge space is needed for evacuation lift. And also when evacuation lift goes to the discharging level, which is typically ground floor, a final protected route should be provided. So people can go safely to a final exit, to a place of ultimate safety, as we call it. So not visiting any other areas which might have a risk of fire. Appropriate signage obviously is needed. Backup power supply is a requirement, as well as maintenance, which is needed for every fire safety equipment in the building. I think probably we have heard about combined firefighters and evacuation lifts in some designs, or maybe we have heard it that it has been provided. So in the current guidance documents, providing combined firefighters and evacuation lift is recognized. However, it is only recognized for disabled people, not for the evacuation of the entire building or for evacuation of all occupants. So if we think evacuation of disabled building, evacuation of disabled people in the building can be done through using firefighters lift. It can be presented through a fire engineer case to approving authorities, and approving authorities in the UK are building control bodies and fire brigade. And if they're happy, it can be provided. But obviously, when we are talking about disabled people in a building, we are talking about a low number of people. We are talking about the entire building. So it has been done so far. It has been agreed so far. But what we have seen at the moment is, if we are talking about providing one single firefighting lift and use that as a dual purpose of serving for evacuation lift as well, it is normally challenged by fire brigade, because it can be an item of a clash between means of escape phase and firefighting phase. So that's normally challenged by fire brigade. So it can be considered as an option, but I would say it is going to be a risk of design until discussed and agreed. However, if a building or a story in a building is provided with two firefighting shafts, then it is reasonable to design of having one of the firefighting shaft or firefighting lift as evacuation lift for people to evacuate, and the other one for fire brigade to access the building and start firefighting. This case has been made in the projects, and it needs a fire engineer support and justification, but it still needs approval from building control and fire brigade. But it can be done, and it can be a design for consideration. I think probably I have another 5 or 10 minutes. So I have only one other topic to quickly discuss. And this topic is a BRE research has been done after the incident at World Trade Center, to identify or to understand if provision of lifts and if the use of the lifts was any useful for evacuation, and if it was helping the evacuation of the buildings. So this research has been led by Professor David Charters with a few other associates. In this investigation, it is identified that in building in World Trade Center, so I'm going to call it WTC2. In WTC2 building, enhancement in evacuation has been happened because of the use of lifts, and WTC1 because lifts has not been available for evacuation or disabled by the time, let's say because of the incident, everyone used the stairs, and actually it delayed the evacuation and actually it ended up with some injuries through evacuation, because when you have high volume of people going through a stair, then some incidents may happen because people fell over and they cannot control themselves. Obviously, you need to take into account for disabled people with mobility impairment, non-disabled but mobility impairment, people with different age or different abilities, so they might be affected through evacuation. So I'm not going to go through every single line on the screen, so I will let you to just read the text. This research demonstrated that providing evacuation through lifts can be an improvement. So in the current design at the moment, or the current situation, we have lifts and escalators as part of the access or egress routes for a building. As I just mentioned earlier, BS 9999 recognizing evacuation of disabled people through evacuation lift, even by using dual purpose firefighters and evacuation lifts. And obviously lifts are provided for fire brigade access as well, which we discussed earlier. So there are a few project examples on the screen. For example, Chelsea and Westminster Hospital, which evacuation through lifts is already considered. This is part of the strategy. And buildings like HSBC Canary Wharf, BT Tower, and the Petronas Towers, they are provided with lifts for helping evacuation. So at the moment we have it provided, but we are having the design as a very performance-based design, which is justified through by an engineering route. It is not as per the code exactly. So yeah, some examples of what we have at the moment. I think probably the next 2 or 3 slides are kind of a main message from this research, which is showing that 27% of WTC to occupants, they use elevators. So something like 1/3 of the occupancy load of the building, they use lifts for evacuation. And the evacuation flow rate means people coming down through the building until the building is completely evacuated for WTC was 2 times of WTC1. So we can say WTC2 actually evacuated 2 times earlier than WTC1, if you just wanted to put it in a simple way. After this part of this study, another evacuation analysis has been undertaken in Hong Kong for Wong building, which demonstrated 36% reduction in time to evacuate and 58% reduction in time for evacuate in the first 25%. So that first 25% means the early evacuation, as we call it in fire engineering, which is important. Because if you have the early people evacuating, they are able to use the means of escape, then the next phase or the phase after, they are not experiencing a queuing time, or the less risk of experience of being in a smoke-locked environment. So that's quite interesting from the findings of this research. However, there are some concerns if you wanted to apply evacuation lifts in the buildings. So for many years we didn't have evacuation lifts in the building. It is recommended to people not to use lifts. If a fire happening, they use only a stair. So if you are going to change of this culture, obviously it takes time and it needs to be taken into account from every kind of design perspective, from training of the people and providing enough information to everyone. Again, long waiting time in lift lobbies is still another concern, because if you want to, for example, evacuate 100 people in a floor plate and we have only a small lobby of 2 by 5 meters, let's say 10 meters squared, then is this enough space for everyone staying there for a certain period of time until they are able to use the lift? So that's probably an item. And is this a good use of floor space if you're talking about like an office? And is it something really a client wanted to consider? So probably an item to kind of understand better if you are thinking of providing lifts as a means of evacuation. Exposure to fire and smoke, again, protection to the lobby at the front of the lifts. Overloading the lift, obviously, it might be another item, because when we're talking about the fire scenario, people are not behaving as they do in a normal day. So is it going to be a problem? Are we going to find an evacuation lift filled by people which actually the lift is not able to operate? We don't know. Probably that's an item to understand better. Power failure, that's another item. Lift pressurization. As part of the draft BS 9991, which is relevant to residential premises, it is suggested that lift shafts are provided with pressurized smoke ventilation. Obviously, this document is still on draft, but is it going to be a problem? Is it going to work with the lift we are designing at the moment? I don't know, probably a topic of discussion for today. Egress complexity. Again, the behavior of people, if they're willing to use the evacuation lift, is there any confusion between choosing going through the lift or staying or using the stairs? Again, another item. So yeah, there are some concerns that I think we need to understand it better if you're thinking to implement evacuation lift as part of the means of escape for a building. And then obviously we can understand it better. We understand the building, the guidance documents are updating at the moment. Obviously there are still some ambiguity in the fire industry, in the lift industry, I believe, how the systems will be managed, which I believe the next speakers are going to talk about those items at the moment. It is a bit of gray area. It is still, we consider from fire engine point of view, a bespoke design, because it needs to be considered based on each building performance until we understand it better, probably until we practice this solution and we understand it better and we find challenges better. So the research summary, which is interesting, is 40% of WTC2 survived evacuating by elevators. Evacuation analysis shows a significant reduction in time to evacuate building occupants, which is obvious if you compare to evacuation to stairs. And also there are some concerns, as we just mentioned, which is human factors, human behavior, which is the reliability and availability for the protection to the lift and lobbies, probably another topic to think about. Feasibility of retrofit design. So if you're saying, is it good, then we go and replace it in every building, or is it possible? Obviously, there are costs associated with that. So I think it needs to be explored in a bigger kind of context, and obviously inconsistency between the buildings, which means again we need to understand the internal arrangement, evacuation strategy for a building. For example, is it simultaneous or phase? And then we understand it actually lifts are any help, or they are improving the design. And I think probably the last finding from this research, which I would like to kind of highlight it here, is evacuation lifts and escalators is feasible. It is a solution. The technology is available. We know it. We can provide it, but involves significant organizational and engineering challenges, which I think probably that's the reason we are sitting here together, to understand it better and see what are the challenges from engineering point of view. We can find a better solution. So I think that was my last slide. Thanks very much. I think hopefully I'm on time. I'm not really going over my time, but yeah, I hope you find it useful.